Morning, Year 5. Welcome back. Welcome back. You're not smiling. Smile more. Right. Okay. Today we're going to do some prime number work. We're going to build to doing some application at the end of the week. But for now, we're just going to work out what prime numbers are. So let's get to it. Right. Let's see. Can I get rid of my face? Here we go. Bye. So we're looking at prime numbers. And what we're going to do is talk about what a prime number is. You may already know this. So it might be a little bit of revision, but you're going to be able to show your awesome mathematical prowess. So the first thing I want to do is talk about how to find a factor of a number. And we're going to start by trying to find the factors of 10. I'm going to wipe out these splodges as we go along. It's my favorite way of hiding stuff. So if we start with the number 10, factors, which I'm sure you know from Mr. Clark's lessons last week, factors are the numbers that multiply together to make that multiple. So 10 is a multiple of lots of different numbers. You can do, and you must do them in pairs. So 10 can be made by doing 10 times 1. It can also be made by doing 5 times 2. And there are no other factors of 10. So there's 10 and 1, 2 and 5. Let's have a look at another one. Let's look at the factors of 5. Well, to make 5, now, important thing to remind you of, which is that factors must be whole numbers. They cannot be decimal. So we can't say, but I know 2.5 times 2. No, no, no. The only way of making 5 using multiplication is to do 5 times 1. That's the only way of doing it. Now let's look at the next one. Factors of 4. Can you quickly on your whiteboard using a pen find the factors of 4? I'm going to give you a clue. There are 3 to find. Okay. Right, good. Let's have a go. So we've got 4 here. To make 4, we can either do the obvious one, which is 4 times 1, but also we can do 2 times 2. Now, because 2 is only going to appear once, we just have to remember that it's a square number. So 4 has 3 factors, 1, 4, and 2. Okay, so the first thing I want to just notice there is what is the same about the factors of 10, the factors of 5, and the factors of 4. What is the same and what is different? Okay, so whoever your teacher is, if you just pause the video and just have a chat about what is the same about those 3 sets of factors and what is different. Okay, so hopefully the thing that you noticed that was the same about all of those was the fact that all of them have 1 as a factor, and that is because 1 is a factor of every number, including 1 itself. But the other thing, I can't think of anything else that you might find the same in all of them, but you might have noticed that 10 and 4 are both multiples of 2, so 2 is on their factor bug. And you can notice as well that 10 and 5 are both multiples of 5. Now, what we're looking today at is what is a fact. How do you know that a number is not a factor? Well, you're going to use your divisibility rules. And you've done that with Mr. Clark already. We're going to go through that again. But that's how we find whether a number is a factor of 4 or 6 or whatever it might be. Okay, so trying to find out what a prime number is. So prime numbers, if we go back here, a prime number is a number for whom it only has 1 pair of factors, and that pair of factors is the number itself and 1. So on that list there, which one of those numbers, 10, 5, or 4, which one of those is a prime number? And hopefully your brain is saying 5, and that's because 5 is a prime number. So you can see here that 5 has got 2 factors. One of them is 1 and the other one is 5. There must be 2 factors. So my question to you is 1 a prime number? Think about the rules. It has to have 2 factors, which are 1 and itself. Is 1 a prime number? The answer is no, it is not a prime number. You cannot have 1 as a prime number. And that's because actually, let's write that again actually. If we try and do all the factors of 1, how many numbers multiplied together make 1? The answer is just 1. 1 times 1. Which means that this number, 1, does not have 2 factors. And it therefore cannot be a prime number. So the first prime number that you're going to come across is the number 2. Okay. And also, if we look at my example down here, we can see that 17 is a prime number. And that's because you could only make 17 by doing 17 times 1. Okay? Right, let's go on to the next step. Now, so there are prime numbers, and those are the numbers which have only got 2 factors, themselves and 1. And there are the other numbers. Now, so 1 is different, but other than prime numbers, all the other numbers except 1 are called composite. And that is because they are made up of more than 2 factors. So composite numbers have more than 2 factors. A prime number has exactly 2 factors. And then 1 is a number which only has 1 factor. Now that will appear on your sheet, so just be very mindful of that. Primes have 2 factors, composites have more than 2 factors, and 1 is a number that only has 1 factor. Okay, so this is just a little table, and you've got this on your sheet, so you don't need to copy it down. But it's just a reminder of some of the divisibility rules to see whether something is a prime number or not. If you can divide it by any number other than itself and 1, and it will give you a whole number answer, that means it's not prime. So 42, for example, you might be quite confident in thinking that this is, well, what are the properties of this number which will tell us whether it's prime or composite? Well, if it's divisible by 2, then it's going to be a composite number. It can't be prime, because that means it will have 42 and 1 and 2 as factors, which means it can't be prime. And what makes you think that it's in the 2 times table? Well, it's an even number, and it's not the number 2. So therefore, this number, 42, is a composite number. And you could go through and find all of the different numbers which are factors of 42, and we could go down here and do that. So we've got 42. Obviously, we've got 42 and 1, 42 times 1. We've also got 21 times 2. And we've got 6 times 7, but we actually don't need to do all of that, because all that we're trying to do is prove that it's not prime. So as soon as you've found that it's in the 2 times table, or it's even, you know that it is composite, and therefore you don't need to do any more exploring. All right, let's look at the next option. So how about 99? Okay, teacher, if you don't mind pausing the video, and guys, can you on your whiteboard find the factors of 99, but stop if you find another one other than 99 and 1, and say to your teacher whether it's prime or composite. Go. Okay, so if we're looking at the factors of 99, we've got 99 and 1, which would make it prime. So if there's anything else, shout them out. I'm guessing you put down 9 and 11. You could have also put down 3 and 33, but maybe you don't get that one. But you can see that this number, 99, has too many factors to be a prime number. 6 factors means it must be composite. Okay. And the last one, I'm going to pause the video after I've unveiled this magical number. It's 23. Okay, so try and make 23 using any factors other than 23 and 1 to decide whether 23 is prime or composite. Go. Okay, and hopefully you found that 23 has only 2 factors. Those are itself and 1, 23 and 1. And that means that 23 is a prime. So 23, I'm going to put a little p here, is prime, 99 is composite, and 42 is composite. All right, now you might need the other divisibility rules here, but you also might just be able to do it in your head. Right, so now in front of you, you should have 100 square. What I want you to do is use your knowledge to try and find all of the prime numbers between 1 and 100. Just a little reminder for you, I'm sure I don't need to tell you this. 1 has got 1 factor, and therefore it is not prime. So what I want you to do is to colour in the ones that are not prime numbers. Once you've done all of that, you'll hopefully have a grid that presents all of those prime numbers. Now this might take a little while, so we're going to pause the video and you can have maybe 5 or 10 minutes to do this as much as possible. I want you to work in a little system. Okay, so I want you to cross off all of the even numbers first. So cross them off except for 1. Hopefully you're thinking which one I'm thinking of. Do not cross off 2. If you cross off 2, because 2 is prime, you'll make a mistake. But cross off all the even numbers other than 2. After you've done that, I want you to do crossing off all the remaining numbers which are in the 3 times table. Cross those off too. Once you've done that, I want to have a little look down and see, can you cross off anything that's in the 5 times tables? You'll have some that have already been done, but cross off the other ones. And after you've done that, the final one will be, I think, to do the 7 times tables. Anything that's in the 7 times table, cross those off too. And you should be left with a grid. So you're going to pause the video now. You can use a coloring pencil, you can use a highlighter if you have a highlighter, and you're going to produce a grid up to 100 of all of the prime numbers. So teacher, if you pause the video, the next slide will be the answers. So only unpause the video once people have finished. Okay? Okay, guys, let's have a little look and see how you got on. So that was the question. The answers were, dun, 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 dun. Now, I've done it slightly differently. My yellow ones are the ones which are prime, but it's just like that, so it stands out for you. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, etc. So those are the prime numbers. Hopefully you've got all of those. If you accidentally didn't cross off one, and this is why yours is slightly different, if you didn't cross one off, now you can cross it off so that you get the exact answers. Those are the prime numbers from 1 to 100. You're going to need those in your questions, so please make sure you've got exactly the right answers. Now, you've got a task, which is a few questions to answer, a little extension at the end. And then if you get to the extension, you're going to be finding the prime numbers to 200 using divisibility facts. Please have a go. At the end, your teacher can show the answers and you can mark your own. Okay, see you later, guys.